Hello, everyone. My name's Eric Paskach, and today I'm going to be taking you through my senior capstone project, Dino Stride, Orthotics-Friendly Footwear for Children. So, 1 in 345 children are born with cerebral palsy. Cerebral palsy is a disorder of movement, and it can affect muscle tone, posture, and muscle coordination, normally found in children. And this not only means that these children need special braces for rehabilitation to correct their gait and their movement, but also special shoes, which is the crux of this project. So, an AFO is a type of orthotic that immobilizes the ankle and basically locks the child's leg in this position. You can see here on the left. Um, it's used in rehabilitation, but as you can see, there's a lot that it adds to the size and shape of the child's foot, which is why special shoes are needed to kind of accommodate this extra space, but also the lack of mobility because immobilizing the ankle makes it so that the child can't flex their foot. So normal shoes won't work with children that use AFOs. So the current market is currently dominated by a brand called Billy Footwear at 43%. Basically, they promote adaptive shoes, but the current market is faced with a lot of problems that parents and children alike both have frustrations with, and this is across the board. These are some quotes from my primary research survey I conducted, and a lot of these problems were also echoed in my secondary research when looking into why this problem space exists. Nothing really fits. You know, the shoes that are promoted as being adaptable just aren't adaptable. But the question is why? Like, why are all of these shoes failing at what they're supposed to be good at? And the problem really lies in what the where the concerns are. You know, there's a massive disconnect in the communication between children, um, their caregivers, the orthotists, and then eventually the designers. And that lack of understanding leads to these misplaced concerns and a final product that completely neglects the needs of the user. So to correct this, empathetic design is something that we can utilize. Basically, trying to understand the user experience and kind of get an idea of what their day to day life is like and actually experience their frustrations firsthand. But this is really hard to do. You know, in the words of Pablo Picasso, it took me 4 years to paint like Raphael, but a lifetime to paint like a child. Children are very hard to design for um, as adults. You know, their minds work differently, and the frustrations that they have and the concerns, the needs that they have are much different than what we have as adults. And designing for a child, you have to kind of think like them, but that's very hard to do. So throughout my research, I wanted to kind of utilize this idea of empathetic design, and I branched out. I took on the role of the orthotist, and I found a lot of things. I found out a lot of things when doing this that you can see on the right there. Basically, the orthotists understand that this is a problem too, and they're really concerned about getting the child rehabilitated correctly, and recommending the right footwear, recommending the right braces, everything. And then in terms of the child, their movement is incredibly restricted when using these, and that leads to such a different life. I got the chance to actually try on AFOs for myself. I took a few days to really experience what the day-to-day life of somebody who wears these is like, and I experienced some of the frustrations and some of the things that the kids go through. It was really eye-opening to experience these firsthand, because even though I was researching these for so long, actually experiencing it gives you a whole different perspective that is really necessary when designing for somebody who is disabled. So throughout my research and kind of honing in on where this project was going, I wanted to come up with some uh, language that really set the criteria for my design. Um, these were inspired by the problems that I faced, but also the ones that I researched. These were the things that were most important to the design, a successful design. And then using that to kind of influence, okay, what needs to change about a regular shoe to make it accessible, to make it actually usable for a child with AFOs. So then I started diving into designing. First off was kind of getting that proportion down, um, or that silhouette down, rather, and really honing in on what elements to include in a design. Um, and you can see where that kind of led. And then next up was the proportion study. So this, a shoe that has to have extra space and a roomier toe box and just be bigger all around. It needed. It was hard to kind of nail down the proportion of what an AFO shoe would look like versus a normal shoe. But eventually, I settled on this design. And this also informed the colorway that I was going to go for. So hopping into 3D modeling, I felt this would be the best way to really nail down what this shoe would actually look like in 3D and be in 3D. Because modeling this, if you're designing a normal shoe, you're designing around a foot, which is a last. However, the only way that this shoe is going to be worn is with an AFO. So I decided to not only use the last, but an AFO as well when modeling around this. And I modeled this in VR to really understand myself how this would function. So here's a kind of a look at all the different parts of the shoe. A few things I want to focus on in particular are the lacing system. The lacing system basically provides like a quick and easy way for the child themselves to lace up their shoe. It's really quick with the toggle, similar to hiking boots. You're just grabbing the toggle and pulling. And then the zipper on the sides that allows the child to kind of get their foot in and out of the shoe. You can open it up and pull the front of the shoe forward, and that allows you to get the entire foot out with the AFO without flexing, because with that immobilized ankle you can't flex. And then like a deeper sole also adds some necessary space, and there's no need for an insole because or I should, like a sock, an insole sock, I should say, because those get taken out of shoes anyways, and the fact that you have the AFO underneath your foot already, it's completely unnecessary. So that saves on cost. Here's a look at my orthographics of the 3D model. So this would be something I could send to a factory to get this made. And here's a look at what this shoe, the final look of this shoe. So calling out some of the materials here, the shoe, I wanted it to be very breathable, because if you have, one of the problems that is faced by children that use these orthotics with their shoes is that they get really hot. Shoes are normally made out of leather, and that paired with the plastic of the AFO touching your sock and then your ankle, it just gets really hot. So you want to make the shoe out of very breathable materials, but also keep in mind that you need that structure to keep the AFO locked in. So you can kind of see how the engineered mesh of the camo pattern combined with the TPU membrane fabric of the mudguard and the heel counter, really embodies that sort of mentality, I guess, when designing this shoe. Here's a look at what this would be on a child with AFOs. You can kind of understand. Okay, they're on the playground. What does this shoe look like? It's very readable from far away, and it makes the shoe kind of fun for the kids themselves. Part of the rehabilitation process is encouragement, and if the child is excited to wear their special shoes, that's only going to help with the rehabilitation process versus something that might look a little uglier or than their friends' shoes, because they want to fit in. So why not give them something that's a little more exciting? And then just a quick look, giving you a better understanding of the lighting and what this shoe would look like in real life. Here's from both sides. And then I actually wanted to make this shoe because I felt like it would be really important to showcase how this would work. On the bottom right, you can kind of see where that ended up. The foot with the AFO, or at least the bottom of the AFO, inside the sole. And then prototyping the upper went through a lot of iterations, but we finally were able to match the 3D model. And then here's kind of a look at the prototype. You can see that the shoe is built around the AFO and the footwear, or the foot last. And then on the left, you can see how it kind of opens up for the whole foot to slide out. But yeah, so thank you for watching. This was a very great project for me to kind of understand empathetic design, and I think that's really important when designing for disability. That's something I kind of learned throughout this project. But I hope you enjoyed, and thank you.